Hi guys, welcome all of you. I am Reena B. George from RVGMATHS and Talents. Now let us start Class 10 CBSE Chapter 1 Real Numbers Part 3. Okay, already we have done Part 1 and 2. I think all of you understood that. Let us start next part. Okay. Here, in this class, we are doing exercise 1.1, question numbers 1 to 7. Okay, let us do the questions together. See the first question, express each number as a product of its prime factors. Already we have studied how to factorize into prime factors. The first question, express each number as a product of its prime factors. See the first one, 140. So we have to factorize 140 into prime factors. 140 is an even number. So we are dividing it by 2. You will get 70. Then again 70 is divided by 2. Then 2 3s are 6, 10. Then 2 5s are 10. Okay, 35, then you can divide it by 5. 35 is divided by 5, you will get 7. 7 is a prime number. 7 is divided by 7, you will get 1 here. You can write the factors like this, 2 times, 5 times 7. Okay, then you can write it as 2 square times 5 times 7. So this is prime factorization of 140. Then come to the next question, 156. 156 is an even number. So divided by 2. Then 2 7s are 14. Then 1 is remainder 16. 2 8s are 16. Okay, we got 78. 78 is again divided by 2. You will get 2 3s are 6. Then 1 is remainder 18. 2 9s are 18. Then 39, it is not an even number, so 2 is not a factor. Then let us try 3. So if you want to find out whether 3 is a factor, you can add the digits. 3 plus 9, then it is 12. It is divisible by 3. Okay. You can divide this 39 by 3. 3 1s are 3. 3 3s are 9. Okay. 13 is a prime number. So it is divided by 13. You will get 1. Then, what are you getting? See the factors. 2 times, 3 times, 13. So, you can write 2 square times 3 times 13. Is it easy? Okay, you understood this. Then come to the next question. 3825, third one. 3825. It's not an even number, so 2 is not a factor. Then if you want to find out whether 3 is a factor, you just add the digits. Then 8 plus 3, 11 plus 2, 13 plus 5, 18. 18 is a multiple of 3, so you can divide this by 3. Then 3 1s are 3, 3 2s are 6, then 2 is remainder 22, 3 7s are 21, 1 is remainder 15. 3 5s are 15. So we got 1275. Again 1 plus 2 3 plus 7 10 plus 5 15. Sum of the digits. It's a multiple of 3, so you can divide it by 3. 3 4s are 12. 3 2s are 6. 1 is remainder 15 divided by 3. You will get 5. Okay. So we got 425. Then if you add this 4 plus 2. 6 plus 5, 11. It is not divisible by 3. So let us try the next number 5, and you know 5 is a factor of this 425 because it is ending with 5, is it? So let us divide it by 5. 8 5s are 40. 2 remainder 25. 5 5s are 25. So we got 85. Then again we shall try this 5. 5 ones are 5. 3 is remainder. 35. 7. 7 5s are 35. 17 is a prime number, you know. So 17 divided by 17 is 1. So we got the prime factors. Okay. So we can write here 3 times 3 times 5 times 5 times 17. So you can write it as 3 square times 5 square times 70. Okay. So this is prime factorization. Okay. Come to the next one, 5005. Let us try 5. 5 ones are 5, 5 zeros are 0, 5 zeros are 0, 5 ones are 5. Okay, 1001. Then it's not divisible by 2 or 3. 1 plus 1 is 2. It's not a multiple of 3. And it's not 5 is not a factor. So let us try 7. 7 ones are 7. Then 3 is remainder 30. 4 sevens are 28. Then 21. 3 sevens are 21. 143. Okay. Then 7 is not a factor here. So let us try next prime number 11. 11 ones are 11. 3 is remainder 33. 11 3 is 33. So 13 is a fact. 13 is the answer. Then it's a prime number. So you can divide it by 13. You will get 1. So you got here 5 times, 7 times, 11 times 13. Okay. So that's the answer. So just verify it. So we got prime factors of these two numbers. Okay. Then come to the next question. 7429. Fifth one. 7429 is not an even number. So 2 is not a factor. Then 7 plus 4 plus 2 plus 9. What is it? 22. It's not a multiple of 3. So 3 is not a factor. Okay. Then let us, the next one is 5. It is not ending with 5. So 5 is not a factor. Then let us try 7. So 7429. If you divide 7, 7 ones are 7 here. Then 4. 7 is not going in 4. Here you put 0. So you take 2 down. Then 42. Then 6 sevens are 42 here. Then it's 0. Then 9 comes down. 7 ones are 7. Then remainder is 2. So it's not divisible. Okay. Then come to the next prime number 11. If you divide the 7429 by 11, we are getting here 675. Here and remainder is also there. So it's not a factor. Then come to 13. If you divide this by 13, you are getting 571 and 6 remainder. 13 is also not a factor. Next, let us try 17. 7429 is divided by 17. So you will get 17 4s are 68. Then remainder is 6. Then 62. 62 is divided by 17. You will get 3. 17 3s are 51. Then remainder is 11. Then 119 is divided by 17. You will get 7. So 119 minus 119, that is 0. That means 17 is a factor. And 437 is the quotient. So you can do here 7429 is divided by 17. We are getting 437. See, 437 is divided by 17. You are getting 25 as the quotient and 12 as the remainder. That means 17 is also not a factor. Then next we try 19. 437 is divided by 19. 19 2s are 38. Then remainder is 5. 57. Then 19 3s are 57. 0 is the remainder. That means 23 is a factor. 23 is a factor. So you can write 23 here. 23 is a prime number. So it is divided by 23. You will get 1 here. Okay. That means 17, 19 and 23 are the prime factors here. Okay. So you can write like this. 7429 equal to 17 times 19 times 23. Okay. That are the prime factors. factors here. Then come to the next question, question number 2. Find the LCM and HCF of the following pairs of integers and verify LCM times HCF equal to product of the two numbers. We have studied this relation. Do you remember that? Okay. So, here we have to find out LCM and HCF, and then you have to verify it, whether it is true or false. Okay. So, the first question is 26 and 91. So, first thing you have to find out LCM and HCF. How to find LCM and HCF? Do you remember? We first factorize it. Okay. So, prime factorization of 26. 26 is divided by 2, you will get 13. So, you can write 26 as 2 times 13. The next is 91. 91, and you know 9 plus 1, 10. So, 2, 3, 5, all these are not factors here. So, you can write 7. 7 ones are 7, 2, 21. 21 can be divided by 7, that is 3. Okay. So, 13 is the quotient. 13 is a prime number. 13 divided by 13, we get 1 here. Okay. So, the prime factors are here 7 times 13. Okay. So, what is HCF here? Highest common factor. So, we have to take the common factors. Do you remember? Common factors here only 13. Is it? So, HCF is 13 here. Okay. Then, what about LCM? For LCM, how will you find LCM? You list all the prime factors. Okay. First thing is that 2 times 13 times 7. Okay. Then, what is next? Highest powers. You take all the highest powers. Here 2 raised to 1 and 13 raised to 1. Here also 13 raised to 1. So, 13 raised to 1. And 7 raised to 1 here. 7 raised to 1. So, 2 times 13 times 7. 2 13s are 26. 26 times 7. So, 182. So, we got HCF is 13 and the LCM as 182. What is the question? Product of LCM and HCF. That is the same as product of the two numbers. Okay. So, LCM and HCF, their product, that is 182 times 13. And if you find the product, that is 2366. Okay. And what is the product of the numbers? That is 26 and 26 times 91. So, that is also 2366. Okay. That means we have verified it. Okay. So, LCM times HCF is equal to product of the numbers. We got it. Okay. Then come to the next question. Find the LCM and HCF of the following pairs of integers and verify that LCM times HCF equal to product of the two numbers. The same way you can do. Okay, let us try together. Okay, start. 510 is divided by 2. First, we want to find out an LCM and HCF. For that, what we have to do? We have to factorize it. Okay. So, 510 is divided by 2. You will get 2 2s are 4. 4 then 1, 11. 11. 2 5s are 10. 10. 2 5s are 10. So, 255. Again, if you 5 plus 5, 10 plus 2, 12. 3 is a factor. So, 3 8s are 24. 1, 15, 3 5s are 15. 85, 5 is a factor, 5 1s are 5, 3, 35, then 7. So, 17 is a factor here, then it is divided by 17, you will get 1. Okay. So, you got the prime factors, 2 times, 3 times, 5 times 17. Have you got it? Then come to the next question. 92. It is divided by 2. You will get 2 4s are 8. Then 12. 2 6s are 12. Okay. Again 46 is divided by 2. 2 2s are 4. Then 2 3s are 6. So 23, that is prime number. 23 is divided by 23. You will get 1. So here we can write 2 times 23. Okay. Then let us try to find out HCF. What is HCF? Can you find out? HCF means, what is HCF? Highest common factor. So you take all the common factors. See, 2 is a factor here, 2 is a factor here. So 2 is common. Okay. Again, then 3 is factor here, but 3 is not common. 5 is not common. 17 is also not common. 23 is also not common. So HCF is 2 here. Are you following? Okay. Have you got it? Okay. Then next is LCM. How will you get LCM? You list all the prime factors. 2, 3, then 5, then 17, then 23. Then take the highest powers. Here 2 raised to 1. Here it is 2 square. Is it? So 2 square. Then next 3 raised to 1 here. So 3 raised to 1. 5 raised to 1. 5 raised to 1. 17 raised to 1. And 23 is also raised. Power is 1. Okay. So LCM is 4 times 3 times 5 times 17 times 23. Then you got LCM as 23460. If you find the product, it will be 23460. Okay. Then we have to verify it. Product of LCM and HCF. So LCM times HCF is LCM times HCF. What is it? LCM is 23460 times HCF is 2. Then its product is, you can find out, 46920. Okay. Then next we want to find out the product of first number and second number. First number is 510. 510 times 92. Find the product. That also you can see 46920. Okay. That means the left hand side and the right hand side are equal. Okay. So we got it. We verified that. Okay. Then come to the next question. Find the LCM and HCF of the following pairs. Same question. We are doing the next one. That is 336 and 54. Okay. Here also, for finding LCM and HCF, we have to factorize it. So 336 is factorized. Then you can find out the factors like this. Okay. So you can write factors as 336. This can be written as 2 raised to 1, 2, 3, 4. 2 raised to 4. Okay. Times 3 times 7. Okay. Next one is 54. 54 can be written as, here it is divided by 2. We have factorized 54 here. Then 2 times 3 is 3 times 3 cube. Okay. Then what is HCF? HCF, you have to take the common factors. 2 is a factor, 2 is also a factor. So 2, then 3 is also a common factor. So 2 times 3, then you have to take the least power. Here it is 2 raised to 1. Okay, here it is 2 raised to 1. So that is the least power. Then 3 raised to 1 here, 3 cube here. So least power is 1. So 2 times 3, 6 is HCF. Okay. Then what is LCM? For LCM, you have to list out all the factors, prime factors. 2, 3, 7. Okay, all prime factors. Then the highest powers, 2 raised to 4, 3 cube, then 7. So 2 raised to 4 is 16 times 3 cube is 27 times 7. You have to find the product. Just find the product. If you find the product of this, you will get 3024. Next we have to find the product of the numbers. See, product of the two numbers. That is 336 times 54. And if you find the product, you will get 18144. Okay. The next thing, LCM times HCF. Find the product of LCM and HCF. That is 3024 times 6. If you find the product, there you will get 18144. That means these right hand sides are equal. That means both these are equal. That means LCM times HCF is equal to product of the numbers. And that is equal to 18144. So we have verified this. Verified this relation. LCM times HCF equal to product of that numbers. Have you understood? Okay. Then come to the next question. Find LCM and HCF of the following integers by applying prime factorization method. We have to find LCM and HCF. I think all of you are familiar with this and it's very easy for you. So you can do it. Okay. Prime factorize 12, 15 and 21. 2 6s are 12. Then 2 3s are 6. 3 is a factor. Then 1. 2 square times 3. 15 is divided by 3. 3 5s are 15. 5 1s are 5. Okay. So 3 times 5. Then 21. 3 7s are 21. 7 divided by 7, 1. So 3 7s. Okay. So what do you got? You can find HCF. Can you find out HCF? What is HCF? HCF is the highest common factor. Highest common factor. So 2 is not a common factor here. 3 is a factor here. Common. So 3 is a common factor here. Lowest power. 3 raised to 1. So HCF is 3 here. What about LCM? We have to list out all the factors. 2, 3, then 5, then 7. Then take the highest power. Here it is 2 here. Then 3 raised to 1, 5 raised to 1, 7. So what is it? That's equal to 4 times, 3 times, 5 times 7. That is 12 times 5. 60 times 7. So 420 is the LCM. Okay. Have we got it? Say this. It is done here. HCF is 3 and LCM is 420. The next question. Find LCM and HCF of the following numbers by prime factorization method. Here 17. You know 17 is a prime number. 23 is also prime number. And what about 29? That is also a prime number. Okay. So you can write 17 as 17 times 1, 23 times 1 and 29 as 29 times 1. So what is HCF? Highest common factor. Here the common factor is only 1. Is it? So HCF is 1 here. Have you got it? Okay. Then what about LCM? For LCM you have to take all the prime factors. That is 17 times 23 times 29. So find the product of 17 and 23 and 29. LCM is 17 times 23 times 29. That is 11339. Okay. That is the LCM of these numbers. Okay. Then come to the next one. Find LCM and HCF of the following integers applying prime factorization method. Same question. Numbers are different. 8, 9 and 25. 8, 2 4s are 8, then 2. Okay. Then 2 cube. Okay. 9, 3 3s are 9, 3 1s are 3. So 3 square. Then 25, 5 5s are 25 divided by 5. you will get 1. So it is 5 square. Then we have to find out HCF. HCF is highest common factor. No common factor. 2 is not a common factor, 3 is not a common factor, and 5 is not a common factor. But what is a common factor? Can you tell? That is 1. So HCF is 1. Okay. Then what about LCM? For LCM, you have to list all the prime factors involved. That is 2, 3 and 5. Then take the highest power, 2 cube, then 3 square, then 5 square. So what is it? 8 times 9 times 25. 8 times 9 times 25. So there are no common factors for here. So here we are getting LCM as the product of these 3 numbers. If you find the product of these numbers, you will get 1800. Okay. So that is the LCM. Okay. So it is done here. HCF is 1 and the LCM as 1800. Then come to the next one. Given that HCF of 306 and 657 is 9, find LCM of these 2 numbers. Okay. So HCF is given and you have to find LCM. How will you get? We will use that relation. Okay, we have studied one relation. What was the relation? Product of HCF and LCM will be equal to product of the numbers. Okay, that was the relation. So here HCF is already given. You can substitute that value 9 and we have to find the LCM and you have to find the product of these numbers. That means 306 times 657. Then the only unknown is LCM, so you can find out that. So first number is 306, second number is 657 and the HCF is 9 given. So what is LCM? LCM is product of the numbers divided by HCF. That means product of the numbers 306 times 657 divided by 9. Okay. So LCM is equal to 306 times 657 by 9. Then you can simplify here. 9 times 3 9s are 27. Then 3 36. 4 9s are 36. So you will get 34 here. 34 times 657. If you find the product, you will get 22338. Okay. So this is the answer. LCM. Okay. So we got it. Have you understood? The next question. Check whether 6 raised to n can end with the digit 0 for any natural number. We have done one example like this. So let us try this. Check whether 6 raised to n can end with digit 0. Already we have seen numbers ending with digit 0. See, these are all ending with digit 0. And if you factorize this, already we have seen that 2 and 5 are the factors of it. Is it? Then 2 is divided by 2, 50. 50 is divided by this, 25. 5 5s are 25. Then 2, 2, 5, 5 are the factors here. Okay. Here also you can find out this. This is 250. You divide it by this 125. Again divided by 5. Then you will get 25. 5 times 5 is 25. Then you will get this. Then here in all these cases you can see 2 and 5 will be factors of numbers ending with digit 0. So if 6 raised to n can end with 0, then 2 and 5 both should be their prime factors. Then 6, if you factorize 6, it is 2 times 3. Okay. 6 raised to n means 2 times 3 whole raised to n. By fundamental theorem of arithmetic, we have seen that prime factorization is unique. That means the only way we can factorize this 6 raised to n is 2 times 3 whole raised to n. And you can see this 5 is not a factor here. 5 is not a factor. That means we cannot find a number n. Find a number n such that 6 raised to n ends with digit 0. Is it? So, we have done all these. Then we got 6 raised to n is 2 times 3 whole raised to n. Since 5 is not a prime factor of 6 raised to n, we can say 6 raised to n cannot end with 0. Okay. Have you understood this? Okay. Then come to next question. Explain why 7 times 11 times 13 plus and 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are composite numbers. That is what we have to prove. Why they are composite numbers. So let us check whether they are composite numbers. See, by fundamental theorem of arithmetic, you can say every composite number can be factorized into prime factors. Okay. So let us try to factorize these numbers. So let us try first one. See, let x be the first number given. 7 times 11 times 13 plus 13. Let x be this. Okay. Then y be the other number. That is y is 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1 plus 5. Okay. Then let us consider this x. See, what is it? 7 times 11 times 13. This is one term. Plus another term, 13. Is it? So consider this. 7 times 11 times 13. Okay. And this term contains only 13 only. Okay. See, here there are two terms. And you can say here 13 is common here. Is it? In both terms we can see this 13. So we can take this 13 outside. So 13, have you understood? Okay. Is it easy? Then 13. If you take 13 outside, what is remaining here? That is 7 times 11. Plus, if you take 13 here, what will be there? 1. 13 means 13 times 1. Is it? 1 is remaining there. Okay. Then 13 times, see what is in bracket? 7 times 11. That you can write as 77. 11 sevens are 77. Plus 1. Okay. That means it is 13 times 78. Okay. That means 13 times 78. Then just check whether 78 can be factorized. Let us try. 78 divided by 2, you will get 2 3s are 6, 18. That means 2 9s are 18. Then 3 is a factor here. 3 1s are 3, 3 3s are 9. Okay. That means 13, it's a prime number. 13 divided by 13 is 1. So we got the prime factors here. That is equal to, here 13 times 78 is factorized as 2 times 3 times 13. That is 13 square times 2 times 3. So this is prime factorization. Is it? So we have factorized this x into prime factors, and this factorization is unique. Okay. So you can say this number is a composite number because it has factors other than that x and 1. Okay. Have you understood? Do you remember that? A composite number is a number which has factors other than that number and 1. So we can say x is a composite number. Okay. Then let us take this y. What is y? Y equal to 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1 plus 5. So here also you can see there are two terms. This is one term and this is another term. Okay. Then you can see 5 is common in these terms. Is it? So you can take this 5 outside. So you can say y equal to, you can take 5 outside. If you take 5 outside here, it is 7 times, 6 times, 5. In the place of 5, you can put 1. 5 means 5 times 1. Times 4, times 3, times 2, times 1. Okay. Plus, you can put like this. 5 is taken outside. Then here 5 ones are 5. Okay. Plus here it is 1. 5 ones are 5. Okay. Then you can write 5 times, what is it? 7 times 6 is 42. And this 4, 3, 12, 24. So you can find out 42 times 24. This is 8. 168. 4, 8. 8. 1008. Okay. 1008 plus 1. Okay. So you can say this is equal to 5 times 1009. If you add this 1009. This is 5 times 1009. That means 5 and 1009 are factors here. That means y is also a composite number. Okay. So we have proved that these two numbers are composite numbers. Okay. So here the solution is given. See here you can see x and y have factors other than the same number and 1. Okay. That means x and y are composite numbers. Okay. Let us start the next question. Question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time, they go in the same direction. After how many minutes will they meet again at the starting point? This is the question. Just explain the question. There is a circular path. See, this be the circular path. Sonia takes 18 minutes to drive one round of the field. See, suppose they are starting from this point. From A, the Sonia takes one round of the field. Again, she reaches at the point A after 18 minutes. Okay. Ravi starts from the same point and reaches back at the same point after 12 minutes. Okay. That means Sonia takes 18 minutes and Ravi takes 12 minutes to complete one rotation. Okay. Suppose they both start at the same point A at the same time, okay, and go in the same direction. Suppose they are going in the same direction. After how many minutes will they meet again at the starting point? That means Sonia starts from here. The first 18 minutes she reaches here. After again 18 minutes she reaches again at A. Again third time after 18 minutes she reaches. Okay. But Ravi reaches at A after 12 minutes. See here, we can say Sonia starts from here and reaches here after 18 minutes. After that again she reaches in the second time. That means 2 times 18 is the time she required. Is it? Then the third time she reaches here after 3 times 18 minutes. Okay. That means she reaches at A at multiples of 18. Okay. Then what about Ravi? Ravi reaches here after 12 minutes. Then second time he reaches here after 2 times 12, after 3 times 12 he reaches third time. That means Ravi reaches at the point A at the time when multiples of 12. Okay, that is what is happening. Or they meet again there at the common multiples. That means the least one is LCM. So you have to find out LCM here. Okay. So the first time they will meet at the starting point is LCM of 12 and 18. Okay. So you find the LCM of 12 and 18. Here 12, 2 6s are 12, then 2 3s are 6, 3, then 1. Okay. 2 times 3. Okay. What about 18? 2 9s are 18, then 3 3s are 9, 3, 1. 2 times 3 times 3. Okay. So what is LCM? LCM you have to list all the prime factors. Okay. Then 2 and 3. Then here 2 square, highest power. Here 3 square, highest power is 2. So 4 times 9, that is 36. So 36 is the LCM. That means after how many minutes they will meet? That is after 36 minutes they will meet. Okay. Have you understood? Is it easy? So factorization is done here. Then we got LCM as 36. That means Sonia and Ravi will meet at the starting point after 36 minutes. Okay. So you got the answer. I think all of you understood it very well. Okay. Then if you have any doubt, you can ask in the comment section. Okay. Let us meet in the next class. Thank you for watching. Okay. Thank you.